Hi, my name is Vanessa.
Hi, my name is Jason.
Hi, my name is Aaron.
My name is Erika, and we just graduated TMU's Electrical Engineering program.
What is it? It is a robotic cat that just does a lot of different things. It can talk, it can walk, it can smell. There's a whole plethora of things, and it's all accessible on our phone application that we made. And you can just see everything on it, and you can control all the things that I just said for the cat.
The purpose of our project was to design a household pet that enhances smart home technology. So integrating different things like being able to walk and be able to perform different tricks that people of any ages could be able to play with.
The principle of it too can extend into other use cases, because it is a pretty general use case right now, but it can be applied into other regions as well. It's like if everyone were to have like a medical emergency or something like that, there's corners of the house that a traditional camera wouldn't be able to access either. There's a camera on it, you can talk, you can move around, so it'll be able to effectively go around the household and still be of assistance beyond just being in a stationary camera position. So there's other use cases that can be expanded to.
For the smells, it's able to detect 4 different gases, which are carbon monoxide, nitrogen dioxide, ethyl alcohol, as well as volatile organic compounds. So based on the combination or percentage of these smells, the cat would be able to detect the smell and say it out loud.
This smells like alcohol.
One of the first things that we had to do was, once we determined the servos that were going to be used, we had to add up the power consumption for all the servos and find a way to deliver power to those servos. And that included determining the thickness of the wires that were to be used. If we used wires that were too thin, they would burn up. If we used it too thick, then it would increase the weight of the cat.
The center of gravity in a robotic quadruped cat is influenced by the placement and weight of its internal components, including the servos, the batteries, the control boards, the sensors, even the wires. To ensure stability, we had to distribute these elements strategically within the cat's body. For example, heavier components were positioned closer to the base to lower the center of gravity and improve the balance of the cat.
We thought it would be like a more challenging project as opposed to the other options that were listed. Not only does this project require one aspect of software or hardware, but also mechanical part that isn't so traditional in the regular electrical engineering program.
It was a good way to mix all of our talents together and to make use of our skill set.
Designing for fall recovery involved several challenges. First, we needed to ensure that all internal components were securely mounted to prevent damage or disconnection even when the cat tipped over. This required soldering, fastening, and reinforcement inside of the cat's body. Next, we had to program the legs to recognize when the robot had fallen and execute recovery motions. This demanded precise calibration of the leg motors and sensors to detect orientation and respond effectively. Object avoidance added another layer of complexity. We used an ultrasonic distance sensor to detect obstacles and program the cat to navigate around them.
We had put ChatGPT into it. We made an entire app for it. We added smell detection, collision avoidance, all those sensors and software that's all built upon it. And just that is kind of what encapsulates the whole multifunctional part of it being beyond just being a robotic cat that moves.
Different sensors and components were connected to the Arduino using wires to allow for locomotion. There was 15 servos or motors that would bend, allowing each limb to bend. There was also a gas sensor that was able to detect smells. And then finally, an ultrasonic distance sensor to detect objects.
We also gave it a personality.
Yeah, there's that too. In the ChatGPT part, we had all the prompt engineering side of things, so it can talk with its own personality, give it its own life beyond just it existing as a movement bot.
So this project was selected by the thesis committee at TMU to be awarded the David Plachnick Memorial Award. And our project was relatively popular on that day, so I think that's what garnered the amount of attention that we did, because it is more of a visual project than some others as well. And as a result of the amount of work that we put into it, people were very impressed and we were awarded this award.
One of the parts of the cat was to make it move, and that requires power. So we had to use our electrical engineering knowledge to be able to deliver power to the servos and all the different components of the CAT.
Yeah, so this was done by using an AC to DC converter and then using a buck converter to step down the voltage. And this would allow the CAT to be able to move.
I think like a topic of electrical engineering is that it goes beyond the scope of just doing the traditional just circuitry aspect of it, but electrical engineering is a more general discipline compared to other disciplines. You know, the aspects related to the actual power distribution and the actual circuitry go to the length of the actual like software implementation as well. And you know, that's something that people don't talk about as much with electrical engineering, but it's still like a big contribution towards being a good electrical engineer.
One of the main differences of our quadruped robot versus most of the quadruped robots on the market is, number one, price. If you look at Boston Dynamics, their robots could range between like $50,000 to $100,000. Our robot was made with a significantly smaller budget, a fraction of that, and it's able to perform a lot of the same functionalities in terms of walking, and it has additional functionalities such as fall recovery and smell detection, object avoidance.
If you think about it in the scope of like consumer level product versions of it, not compared to Boston Dynamics.
Yeah, it allows household regular people to be able to afford a robotic cat, a quadruped robot, versus just industry. In my opinion, the most challenging part of the project was the electrical component of the cat. The cat required a lot more power than we initially anticipated. One of the requirements was fall recovery, and for that, the motors required a lot of torque. And because of that, we needed to have a lot of power for the cat. However, increasing the amount of power that can be delivered to the cat, it increases the cost and increases the weight of the cat, which also led to more issues with fall recovery.
One of the most challenging parts that we experienced as well was also the working on the legs. So like Aaron was mentioning, it goes beyond the scope of just the actual servos itself, but the actual physical legs would often break because of the weight of the cat. And that had to do with the printer that we were using at the time.
One of our biggest hurdles was achieving the right balance of friction. Too much friction in the joints, and the servos couldn't move the legs. Too little friction though, and the legs lacked stability, causing the cat to stumble or simply skip over movements.
And so we spent a lot of time just fixing legs, attaching legs, and trying to work on the actual physical, mechanical side of it.
It was important to strike a balance between finding strong material to use for the legs while not making the cat too heavy.
Synchronizing all four legs to work together required extensive programming and testing to replicate smooth and natural movement. This task often felt more aligned with mechanical engineering, but it taught us the importance of interdisciplinary collaboration.
I think the course that helped me the most was ELE 202. It was the Introductory to Electrical Circuits course, and it was like the basis of everything that we do within electrical engineering. No matter which stream of electrical engineering you go into, you need some knowledge from there.
I think one of the most useful courses for me for the scope of this project would definitely be COE 528. The main takeaway from it being knowing how to visually show UML diagrams to illustrate how the software of the project's working from a different perspective, from a more design point of view as opposed to just the actual programming part.
For me, the most useful course was ELE 754, which was Power Electronics. So this fourth-year course really helped in learning how to utilize converters such as a buck or boost converter to change the power levels, which was used in the design of the cat.
In addition, ELE 504 was very helpful. In that course, we do a lot of circuit design, and a lot of that helped with designing the electrical power support system for the cat. The next step for me is to work at the ISO as a power system analyst. I will be spending the next few years delving deeper into power systems and trying to model our Ontario grid and to help keep the lights on within Ontario. In addition to that, I will be attending a master's program at the University of Toronto. That's going to take a few years, and hopefully with that, I'll have more knowledge on power systems.
The next step for me is I'm working at AMD as the AI program manager. So the future for me is a lot to do just with AI and machine learning. I'm also going to University of Toronto for a master's as well, and I'm specializing in machine learning and computer engineering in order to try to just build on my knowledge right now coming out of electrical engineering too, to just be more effective at implementing more AI at AMD.
I was really interested in the project management side of this project, and I was also interested in integrating technology and business together. So I will be pursuing a career as a technology consultant at Protivity and hopefully look towards doing a master's in the future as well.
I'm currently working as an electrical designer at DEI Consulting Engineers in Waterloo, where I specialize in designing electrical systems for schools. I am currently working towards getting my designation, and eventually I want to move into designing systems for waste and water management facilities.
My advice is definitely to take resources provided by the university. So being involved in things such as research positions, as well as different extracurriculars, can allow you to gain more experience outside of the classroom.
Some advice I would give to a first year is to pursue a minor in computer science, or at the very least to learn some coding skills. This is very helpful within the industry, as a lot of electrical engineers within the industry, they don't specialize in that, and it could help you automate a lot of your tasks, make your processes more efficient. It's very helpful.
I think my word of advice would be always take other opportunities outside the classroom to learn things. You know, I know traditionally with electrical, you would assume more to be on the hardware side of things, but me throughout undergrad, I was always very involved in like the hackathon world of our university. I used to be the co-chair too for like the school's hackathon for a little while, and you know, I did a lot of things in that sort of software community, which is kind of what led me to where I am today and how I know significantly more outside of the classroom and with respect to software, especially outside of the traditional electrical engineering program as well. So I would always just say, just like do things outside the classroom.